Welcome viewers. In this video we are going to discuss construction types of warehouse structures. Basically the construction types are divided as per the materials which we are using. So generally it is a steel structures and concrete structures. It is a two types of construction types which we are going to see. Also in practical there is also another construction types, that is underground structures. So underground structures we are not going to cover in this because it is having so many challenges in design and constructions. So let me look into these two major parts. This is a major two, three are these two are the predominant construction types in warehouse structures. So first one is the steel structures. Under steel structures there are five categories. One is portal frame structures. The second one is normal frame structures. It is a movement frame structures. Third one is steel truss structures. Fourth one is steel grid structures. And finally in the fifth one it is a cold form thin walled structures. So these are the five basic steel structures under warehouse constructions. And coming to the concrete structures, there are two major things. One is pre-stressed concrete structure, another one is normal conventional RC frame structures. So again this pre-stress concrete structures is subdivided into two, that is pre-tensioning, another one is post-tensioning concrete structures. And as we see that the third one is RC frame structures, which is a conventional type of constructions. And again in the steel structures, as we see that various five different types of structures. So this is a view of that structures. So number one is portable frame, portal frame structures. So you can see in the left hand side the picture, which is actual construction photos. So which is having a portal frame as a column, equally spacing column, which is connected to the rafter. So all these two columns and the two rafter, that is from the left to mid and the right to mid. So these two rafter which are connected with the tie members throughout the length. So this kind of arrangement is called as portal frame structures. So the portal means the column and the rafter used to call as a portal, whereas at the end we used to provide some wind post. So you can see in the at the end there is a two vertical columns that usually we used to call as a wind post column. So this reduce this in terms of acting the wind forces, and the wind forces distribution will be happening during this wind action when there is a wind post is provided. So similarly in the right hand side there is a picture which is a staired model view for this left hand side construction type. So this is all called as a steel portal frame structures. The second type is frame structures. So here the frame structures usually have the column, beams, tie beams, secondary beam, primary beam, which are also having some cleat angles to connect the columns to the beam, and beam to beam column also we used to have some splice connections. So these are the parameters which we are used in frame structures. So the frame structures is mainly for the multi-storied usage of warehouse. The portal frame usually used to have as a single storage, that is at ground floor. And now this is a steel truss structure. This is a third type. So generally for roof system we used to provide some steel truss type of structures, which is built with the angles and pipes. Generally these are used to do with the connection of bolts. So majorly this type of connections are hinged at both the ends, which to be rest on the column. So this is a one type of construction in warehouse structures. So again this truss type also there are a few types which are listed here. Parrot type truss, Warren truss, and queen post truss and king post truss are the major usage in most of the warehouse construction. And Howe or double Howe truss generally to be used for large span of truss where there is no intermediate support. and fink or double fink is another type of truss. So depends upon the requirement this type of truss to be decided and the type of construction methodology also used to decide. And this is a fourth method, the steel grid structures. Generally these steel grid structures are having a group of members which are connected at a single node. See, you can see here that at the bottom card there are various members are connected vertically and inclined. At this point you can see that 1 2 3 4 number of frame structures members are connected to the single node at the card, at the lower card. Similarly at the top card there is a 2 3 4 1 2 3 4, there are 4 to 5 numbers of members are connected here. So likewise these members to be connected as flexible nodes. So you can see in the right hand side there are the animation pictures which is having number one is a ball and socket arrangement, another one is similar like of ball and socket, and the third one is coupler kind of joints. So these three kind of joints are mainly used in this steel grid structure type. So this is mainly applicable for the roofing for large span where there is no intermediate support. This range up to some 100 meter of span. So this type of structures frames for under construction types for warehouse is called as steel grid structures. And the finally is a fifth type is a steel cold form thin walled structure. So you can see the various profile which is in Z shape, C shape with the lips and double top hat channel sections. And in the here you can see in the left bottom is a sigma beam, and this is angle with lips, and these are the sheets, corrugated sheets. And there are special sections which is to be used for steel cold form thin walled structure. Z purlin which is to be used for roof cladding. Lipped channels can be used as a columns also. The top hat section also can be used as a columns. Sigma beams for side rails and main beams. Lipped angles for bracings. Sinusoidal steel sheets can be used for roof sheeting and wall cladding. So these are the typical form of sections as per European standard EN 1993. So for single open sections you can see here these are the various type of single open section which are available, and open build up sections. So double channel back to back, double channel with lips back to back. So here single channel with two angles back to back and two unequal angles back to back. So these are the common type of sections which are available in European standard. And closed build up sections, double channel which are connected with flat sheets. Here toe to toe double channel with the lips. So similarly for beams and other members subject to bending, these are the various form of cold form thin wall structures are to be used. So this is all about European standard sections. So this kind of sections will vary according to the country standards and the global standards. So this is our other type of profiled sheets and linear or liner trays. So these sheets can be used for wall cladding and roof sheetings, and these are the compression and tension members. And this is a typical view of or construction view of cold form thin walled structures. So this warehouse is built with cold form thin walled structures. So all members are cold form here. The column, beams, ties, claddings. So all those materials are built with the cold form thin wall structures. So let me look into that comparison between all these five types. So first criteria or category is a load bearing components. So here majorly the portal frame structures, the load bearer components are hot rolled welded profile, which is to be used for main structural members for columns, beams, rafters, tie beams and bracings also, and cold form to be used as a secondary supports like purlins, side rails. So these are the secondary supports to be used. Also sometimes the door openings also can be used as a cold form. And frame structures, if it is coming for that, load bearing components are mainly the beams and columns. All are rolled sections only, and steel truss structures, upper and lower cards, purlins, truss, which is a vertical small member in between the truss, and slings is an inclined member. So generally that struts used to hold the compression loads and slings used to hold the tension members. So here the upper and lower cards will hold the tension and compression which is formed due to the wind, and purlins used to hold the roof sheetings, and bracings are diagonal which is to be transfer the loads to the main card. So these are the parameters used in load bearing components in steel truss structure. And coming to the steel grid, it is built with rods with space nodal connections. So the where the connection is a major things here, which is transferring the loads between the members. Under the steel cold formed thin, the Z purlin, lip channels, columns, sigma beams, these are the members to be used for load bearing components. And the second comparison or second criteria is between the seismic and wind, how the ductile property begin for the seismic and wind. So portal frame is a good in a ductile so that it can hold more seismic or wind forces, and frame structures can be medium because the lot of movement connections are there for frame structures. So this will some that transferring the force may be not a good for in medium, so it is called it as medium ductile. And for steel truss and steel grid structure, those are having a hinged type of connections with the bolts and flexible connection which can allow the rotation. So this will give better ductile compared to frame structures. And the steel cold form is always having no weak or no plastic stresses capacity. So this will be weak in seismic and wind criteria, that steel coal form thin wall. So generally this is not applicable, this is not to be constructed where the seismic or wind impact is higher. Third one is rigidity. So as we discussed in the last point, all the four, that is portal frame, frame structures, steel truss and steel grid structures are having a high rigidity due to their connections, but the steel coal form having a buckling and instability issues. So the rigidity is a weak here in a steel coal form thin walled structures. And material is always light in portal frame and somewhat medium because this requires some moment connections which will increase the weight of the materials. Also if it is going for a multi-story, then the steel weight is going to increase because the bottom lower column will have higher sizes. So gradually it may be decreased due to the curtailment, but there will be some increase in the steel. So this we can keep it as a medium weight. And steel truss structure is always a lighter, and steel grid structure is always lighter than all the other four categories. And steel coal form also a lighter because these sections are thickness are very less, maybe it won't go beyond 3 mm, all the sections are. So this also a lighter section. So another category is engineering complexity. In portal frame it is a low because the major things we need to concern is only the column and the rafter. So if the column, rafter and wind post is decided and only the deflection criteria is okay, then we can say the engineering solution can be over because the connection aspect it is not having much. So only the connection between the rafter and the column we need to concern more. But in case of frame structures, in each and every member we need to check the connections, because all the members are act as a major members, beam, columns, tie members, sag rod also we need to consider that. And the steel truss structure is also a medium, because this is also having so many bolt connections between the lower cord and upper cord, rafter, purlin, and stud slings, gusset plates. So a lot of connection systems are there. So this is complexity is there in. And steel grid structure, so this kind of structure also having a high complexity of their connections. So where we need to provide the hinged connections, where need to provide the flexible connections, and how many members to be connected to the same node. So these are the challenges which is having in while doing the design of steel grid structures. And coming to the steel cold form thin walled, so here also it is a medium, so that we need to decide a lot of members based upon the thickness, and the connections between the two members also little bit challenge compared to other portal frame or frame structures. So this is also a medium one. And construction complexity, portal frame is very simple. We need to rest all the main column and connected the rafter, then the ties which is required, and after that we can fix the cladding or roofing. So those can be connected using purlin and side rail. So these are the simple complexity is less, I can say, for construction for portal frames. And for frame structures it required some lifting and transportation, so we can keep it as medium. And for steel roof structures, the connections will have some more complex way. So, and for steel grid structure it is a high, because the connections is challenge little bit, and also the tolerance also need to consider. Steel cold formed thin walled structures is the same like portal frame structures. So there is no complexity while doing the construction. And purpose other than warehouse. So that portal structures can be used in other purpose like industrial, commercial, agriculture, and institutional. And whereas the frame structures is a multi-storied, high-rise, super-rise commercial building also possible, and also office and conference halls, bigger or multi-storied conference hall also is possible with the frame structures. So with the frame structures, we can lift many floors based upon the bearing capacity of the soil and the functionality requirement. And coming to the third type, steel truss structure. So this can be used as a bridge, mast towers, which are subject to more ductility, and corridors of industrial buildings. So this kind of requirement, steel roof truss is best suit. And gymnasium for steel grid structures, gymnasium, exhibition hall, aircraft hangar, large airport, and railway station roofs. For this, steel grid structure is better, because we can go with a large span without having any intermediate column or vertical supports. So aesthetical view also this will be very good in steel grid. And coming to the steel cold form thin walled, this is good for seismic prone area, but as it is a lightweight, there will be challenge in seismic area. Actually it is some special ductile procedure to be provided here. Next one is benefits. So for portal frame structures, it will provide a space utilization is flexible as no interior columns, because here the columns we used to have only in the exterior face. So all around the length of the building and width of the building we used to have the column. There is no internal column. So the space can be utilized properly in portal frame structures. Whereas in frame structures, the benefits is multi-storied structures. So the multi-storied structures is possible with the frame structures. And the third one, for steel truss structures, the curtailment and splicing members are easy, because for overall the span, if it is having a 20-meter means the curtailment, wherever the actual depth of the beam member is required, that area we can provide, and remaining thing we can make it as a splicing, and we can reduce the depth of the upper card and the lower card usage. Based upon the usage, the section we can reduce, so that the weight can also reduced. And the next benefit is it is a lightweight during lifting and transportation, because the entire truss member which is having more than 20 meter or up to 50 meter, we can do it small pieces, and we can lift that and doing the transportation after sending that to site or the project location, then that can be assembled at the project. So the lifting and the transportation is a good benefit in steel truss structures, so that the small piece of members can be transported to a project site, and there the assembly can be done, because all the members are connected with a bolt, so we can fix at project site itself. And steel grid, there are the benefits with the column free spans. Even this can be span up to more than 100 meter also. So accordingly, the steel grid, there is no column in between. So this will also give a more space utilization and more resistant to seismic. And steel cold form also resistant to seismic. And compared to steel and concrete, these are the benefit, because all the five steels structure types are having the same benefit of this low carbon footprint and use less energy, recyclable. But this kind of benefits is not applicable for concrete. So because the concrete will have a mass debris, if we are going to dismantle the structure, then it will create a lot of carbon footprints. Also the labor, the construction labor activities also more in concrete structures compared to the steel. So all these benefits are okay with the steel structure rather than the concrete. Also the concrete is not a recyclable, whereas a steel can be recycled. So we can dismantle from one location of the steel structures, and we can reassemble to another location with some minor additional weight and additional cost. So that is possible with the steel structures. Now let we look into that concrete structures. So this is a pre-tensioning concrete structure, you can see on the image. So here that column and rafter beam are designed somewhere in factory, so that the factory, the sizes will be decided according to the load and the span. Then it should be transported to the project site, and the assembling will be happen using the lifting crane, all those things. So this is a pre-tensioning concrete structure. This is another view of pre-tensioning concrete structure. So this is post-tensioning concrete structures. So the difference between this pre-tensioning and post-tensioning is a pre-tension concrete can be done only in the factory. Once after the concrete beam or column is casted at the factory, then that should be lifted to the site project, and only the assembling to be happening there. But in case of post-tensioning concrete, the structure to be partially fabricated in factory, and then that should be bring to the site. Say for example, column should be casted at site, and beam should be factory made, that should be come to site, and both the things to be assembled there. And once after assembled the column and beams, the slab should be laid over at site. Then the slab should be installed with the tendons, and the post tensioning process to be happened at project site for slabs. So these are the difference between the post tensioning and the pre tensioning. Also the post tensioning can be classified into two. One is unbonded, another one is bonded post tensioning. So this is a coupler with the tendons. So this to be applied in the slabs while casting at site itself, and later after, before the shuttering, the tension to be released, so that the tendons will provide more stress on the concrete, so that the concrete will regain its strength. So this way this post tensioning process can be done. And the third category in concrete structure is RC framed structures. So this is a conventional method doing the formwork at site reinforcement, placing the concrete inside the column, and after the concrete was set in the column and curing of the column is completed, then the beam should be done with overlapping the reinforcement beam reinforcement to the column, and again the beam formwork and laying the concrete of beam. After that, once the beam is casted, then the slab to be cast. So this will be a sequence of constructions: beam, column, slabs, and finally the internal parts. So like that it will be happen. This is a conventional method of RC frame structures. And next is a comparison of concrete structures. For pre-tensioning and post-tensioning, the tension cracks can be eliminated, also reduce the risk of steel components corroding. But in case of RC frame structures, occurs when tensile force exceeds the concrete maximum tensile stresses, because here the concrete is weak in tension and the steel is weak in compression for RC frame structures. But in case of pre-stressed, that is pre-tensioning and post-tensioning concrete, the concrete will regain its strength, which will have a more tension carrying capacity compared to the conventional RC frame structures. So next category is next criteria is shear stress. So shear stress are reduced in pre-stressed concrete, that is pre-tensioning and post-tensioning concrete structures. And if the tension forces are not resisted by concrete in case of RC frame structures, then the shear reinforcement to be provided. Third category is a compression stress. So concrete compressive strength is used for its fullest in case of pre-stress, that is pre-tensioning and post-tensioning concrete structures. But in case of RC frame structures, triaxial compressive stress concrete expands outside cause tension around concrete. Because in two directional for beam members, if we are going to apply the axial forces, then it will carry the compression stresses. If you are applying the compressive stress on the beams, it will carry the compressive resistance. If the triaxial compression, it means if you are going to act a other side instead of x and y, if you are going to apply the z direction, then there will be a outward tension which will cause compression to the concrete. So that means the RC frame structures is weak in compression in case of triaxial compression stresses. But in case of pre-stressed concrete, this triaxial can able to bear by the concrete structures, as the compressive strength of the concrete can be used fully due to the pre-tensioning pre-stressing method. The fourth category is section properties. So for pre-stress, pre-tensioning and post-tensioning concrete, thinner and lighter than RC framed type. It is a non-standard shapes also is applicable, but here in RC frame structure it will be heavier than the pre-stressed, whereas for longer span we need to provide higher depth. There are some span to depth ratio is there, and standard sections only is applicable. Only the rectangular shape, circular shape, or square shape is possible with the RC frame structures. But in pre-stressed concrete, the section properties can be modified, even the non-standard. According to the required depth, we can go with that. According to the curtailment, the wedges shape can be differ. Uh, it, it won't be a non-standard shapes. So any shapes we can use it. So likewise, this pre-stress is having a good benefit of section properties. So we can do some optimized sections for that. And next effect is Hoyer effect. So this Hoyer effect is applicable only for pre-tensioning. So this is not applicable for post-tensioning and RC frame structures. Hoyer affecting means the change of the original diameter at the end due to the reduced value of the transmission length. Mainly for the continuous beam, when there is a effective force distributions is considered while doing the pre-tensioning, there will be a less requirement of wedges, or edge depth is required is very less compared to the other two cases like post tensioning and RC frame structures. So this is possible with the pre-tensioning concrete structures, so that this can helps transfer the pre-stress from the tendon to the concrete. So it will optimize the sections of the concrete members. Concrete. Then next one is preferential scenario. So in that, when structural elements are small and easy to transport, so this is applicable for pre-tensioning concrete. And for when structural elements are heavy, so then we need to go for post-tensioning concrete structure. Say for example, if the concrete slab to be cast at site for a higher span or a higher area, then we can go for post-tensioning concrete structures, because it will have partially the beams can be considered as a pre-tensioning concrete structures, whereas the beam depth and sections are less than a meter, so that can be used, that can be easily transport to site, project site, after manufacturing at the factory. So only the beams and columns we can do with the pre-tensioning concrete methodology, and for slabs we can go for post-tensioning concrete structures because of the widen or the span of the member. The possibility of the transportation is risk. And coming to the RC frame structures, the structural elements are heavy, then it can be cast at site. Even if the concrete is very heavy, if it is required for multi-storied warehouses, then we need to build that conventional method of RC frame structures only. Whereas if the column sizes is too much, which cannot able to transport through any methodology, then we need to go for RC frame structures. So this is a preference scenario. Next category is engineering complexity. So for pre-tensioning concrete required a specialist in pre-stressed design. Also the same for post-tensioning also. Then assess strength losses. So we need to assess the strength losses due to the tendon bending. Suppose the wire, all the wires are in same line or straight. There are various losses in case the shrinkage losses is there, tendons shrinkage losses, and concrete moisture losses. There are various losses we need to calculate strength losses. Then after that only we can able to arrive the exact load bearing of the pre-tensioning concrete structures. Transportation and lifting. For this we need to provide some information about where to fix the lifting lugs, and the center of gravity to be calculated while lifting, and transporting the lifting points to be fixed exactly, so that engineering complexity is there while doing this. In coming to the post-tensioning concrete, loss of strength to be assessed the same way of pre-tensioning, except in the pre-tensioning we need to calculate this transportation and lifting loads also. RC frame structures, there is no engineering complexity, so it is a conventional design procedures we need to do it. A lot of codes parameters are there that we need to consider, that is more sufficient for that. And load balancing concept, pre-stressing tendon is designing for pre-stressing force and eccentricity to balance the dead load. So for a continuous beam, if it is going to happen, then we can able to do the load balancing analysis, so that where the actual load is going to occur, where only for that area, that section we can provide a deeper or optimum. Accordingly, the balance load transfer can be possible with the pre-stressed concrete, that is pre-tensioning and post-tensioning concrete structures, but it is not applicable for RC frame structures, because in RC frame structures we need to provide the entire beam sections for uniform, and uniform where the requirement of the depth is, it's not depend upon the loads. And workmanship is pre-tensioning and post-tensioning, that is pre-stressed concrete requires skilled workmanship, but for RC frame structures it is conventional concrete construction skill is sufficient. Next one is space usages. For pre-tensioning and post-tensioning, large span beams with no intermediate columns provided good usage of floor spaces. Less depth of beams provide vertical spaces and reduction of overall building height. So this is possible with both, even the span also we can construct large and no intermediate column is required. Also the vertical depth can also optimized. Similar like that RC frame structures, intermediate column location consumes space and internal accessibility, requires more building height as the beams are deeper for long span. Linear transformation in beams, higher vertical of load capacity, reduction deflection of the midspan, require fewer tandem anchorages, redundant load paths, strengthen the structure and minimizing its weights. So these are the positive linear transformation in beams, but in RC frame structures these are not possible. So these are all about construction types of warehouse. Let we look into another video for more technical points for warehouse. So that video we can cover factors for warehouse design, structural components in for steel and non-structural components, geometry, dimensioning, design input, classification of structural loadings, design procedure for warehouse structures, failures of warehouse structures. So that we are going to look more in upcoming video. Thank you now.